So what I'm going to do today is, I think you are pretty familiar with the disaggregation, but I'll go through some of our philosophy or understanding where it is going. Talk about the chips. You've heard about the chips that already are there, but there are also newer chips that we're going to talk about. That's basically the breadth of my presentation. And these chips, I'll go over it. One thing I do want to advise you is that there are certain questions I won't be able to answer in a public forum, unfortunately, because of the sensitivity of competitive nature of things. But I'll try my best wherever I can answer the questions. Okay? So, so point is that talking about Broadcom and disaggregation and how we perceive the market going forward. So you all have seen, may not have seen this picture, but about a few years ago, I encountered this article from HP, which actually started it all almost. They turned the box aside on the side, vertical to horizontal, saying, hey, this is the opportunity to really use Linux and use products and being able to disaggregate the model such that it brings benefit to the end customers. It is the kind of revolution that I saw in my lifetime. I was at Chips and Technologies a long time ago. I was at AMD and et cetera, and Lucent. That in the PC market, a disaggregation happened, and suddenly, everything moved from the motherboard, which became a commodity. The value was in the silicon, which is the merchant silicon and software. And Microsoft kind of took it over and has an ecosystem now that enables them to still do the same disaggregated kind of an approach where they take their developers outside Microsoft and bring them in. Similar thing is happening, the transition is happening in our networking world. And in fact, I think it's going to be very, very successful. That's our belief. The time is now. Why disag? I think disaggregation really is being driven by the DC and the telco operators because they feel that they need to get the benefits out of being able to deploy automation, efficiency, virtualization, security economically and with the agility they need. The vertically integrated OEMs, they are not able to do that agility, that extensibility. They're not able to perform it in the flexible and the time frame that our service provider and DC operators need it to be. So therefore, it falls upon the disaggregated market to go and provide that solution. Broadcom has recognized this trend as an opportunity, okay? And we'll walk through a few slides. I think some of it is evident from the earlier presentation that we are very heavily participating in this market, and pretty well engaged with the Acton as well, quite a bit in this market. And I'll talk more about it. I did want to say a little bit about what the analysts are saying. Now, there's not a lot of analytical data right now because the market is starting to perform, but there has been some surveys of the surveys of the enterprise customers, 70% indicated that they agreed with the adoption of disaggregation. And one of the motivation behind it is that someone was talking about it here, that virtualized applications running over network, and they want to run it over SDN. This basically, I think that is also kind of a way moving forward that people would like to go and look at disaggregated products. And the third item that is critical is open systems, and that has also been talked about here. One of the enablers, and as you all know, Dell EMC, Open Networking, OCP, ONI, and SCI, Microsoft SCI are all gearing towards it. We at Broadcom are also offering an open version of the SDK being the software that is underlayer above the chip that allows IPI to integrate their software with us. And we are offering an open version on one of the most popular chips right now, Tomahawk, and on GitHub. You're more than welcome later. You can ask me what the pointer is, but that is something you can play
Can I ask you a question about this? So,
yes.
Say a new ASIC family is released into the market, how long does it take for you to publish the SDK for the new family into the open community?
Okay, so we are
because
looking,
you understand that the problem here is velocity, right?
Yes.
And
yes.
if you say, yeah, Tomahawk 3 is being released Q1 2019, whatever that is, probably earlier, and then we're gonna release the SDK 6 months later. Of course, that would give whoever doesn't use the open SDK a vantage point, because they would be able to be faster, right?
Yeah.
And the other question I had is SAI, right? So having this common and standard interface to the silicon is, to me, it's a magic unicorn here, because my understanding is that Strata X doesn't use it. Arista EOS doesn't use it. So I'm kind of thinking, there is this magic idea, but nobody's really using it. I mean, the major ones.
Well, the position size, it's also emerging, okay? I think there are people who are looking at it, and some of it is being forced by Microsoft. But there are other efforts to actually, Broadcom is also working on certain projects where they are trying to open up their APIs in a certain ways. Some of it is OpenNSL that you might have heard about. But we are also looking at what is the best way to do that. It is tough to do a common API because of the fact that you have pipelines, and everything is pipeline dependent. SDKLT, one of the interesting things is it is actually independent of the pipeline. It takes the behavior out of APIs. It uses a table form, table-driven programming, which means that you program everything reflected in a physical table inside the chip. So there's a physical view to it. I can get into more details later. In interest of time, I will jump to the next slide. So this is the landscape, right? We have silicon, merchant silicon. And merchant silicon, what is the thing? Like I said earlier, the motherboard is just commoditized. The value is in the silicon. Standardization and Moore's law is all driving us into that the whole system is really on the chip. And as I will show you, Jericho 2 is a core router on a chip, okay? So what is happening is people are looking at that and saying, maybe we can do something here. So at least as some of you have said, that the data centers are really moving towards this disaggregation as the lead. Then you have hyperscalers, then you have the service providers, and they are also moving in that direction. Not a lot, but there are a few big, I would say, service providers who are actually starting to do that. Then you have the enterprise. It's also moving in that direction, but slowly. But in each of this case, except the government industrial manufacturing, you see merchant silicon as being a key component. And I think what will happen is, as it disaggregates, things will move upwards. Hardware will become commoditized. All the ODMs will participate. But the merchant silicon is in all these areas: switching, routing, transport, backhaul, and more.
You specifically called out the advantage being in data centers. Do you see that progressing to branch office and campus networks as well, or why the reason for just data centers?
I do believe it's going to happen with the campus network, and Broadcom is going to enable with their silicon as well. So our plans is to get everything out there that we believe would be enterprise or for the data centers out there in ODM boxes. So this is another view. I'm kind of put it backwards because it looks kind of odd for people. So this is the box. We are trying to serve this market here, right? And as I said, I mean, it's starting here, gradually going here and here. And both of these kind of are not stacked correctly. They should be parallel. They both are getting the influence of disag. So we are working with vendors, and Acton is a prime leading. And thanks for talking about us a little bit. But we are very heavily involved with Acton in a lot of our programs. And I'm not allowed to say which ones. You already talked about few, and a few will be in the slides. And then for the NAS software developers who are, IPI being an example is our NAS partner. And then on top of that, the NAS partners are working with the services organization, tracking about Ansible, Kubernetes, and all that automation products and security products that they are integrating by giving their northbound APIs to them, and then seeing how they can integrate it into the system and into the the supervisory layer of the SDN controllers, etc. So the next slide is here where we talk a little bit about what we are doing in terms of the disaggregation. Our efforts are to take am I being okay here? You can see me on the screen? Yeah. Mm-hmm. All right. So that examples here, okay, there are many others. Facebook or AT&T on these, we work with those customers. We have a group dedicated to working on developing, working with them on technology roadmap, RFIs, RFPs, POCs, and field trials, and also looking at their data center architecture and getting some feedback. What that enables us to do is provide new devices or new capabilities in our silicon. We work with the ODMs when our silicon is in planning. We have a pretty tight relationship with them that we do re-release discussions with them, share our roadmap, and they share their roadmap and work towards all the ecosystem for the ODMs. On the other side, it is IP Infusion, who is a very close partner of ours. We have done several devices here: Helix 4, Trident 2, Trident 2 Plus, Qumran, MXAX, Trident 3, and Jericho Tools is something we are planning in going forward in the future. But we have a very tight relationship, and how it works is that they talk to their end users, we talk to them, we prepare technology. When they want something, we already most likely have the technology. And of course, the silicon has already been implemented in various configurations on the box.
Can I ask you a cheeky question? But it's genuine curiosity that I have. My understanding is that you have a team of people working on a NOS, right, which is Strata X. How would you see that compatible with your relations with companies like IP Infusion or Cumulus or?
I think
are they comfortable with this?
I think it is pretty compatible in the sense of can coexist, and we know how we are working in a way that we don't conflict with each other. I cannot say a lot more than that.
Yeah.
Okay. But yeah, we do care about these partnerships as well.
Yeah, of course. Yeah.
It's very important for us. This market is very important, so we do believe that we will not compromise that. We'll work in a way that is compatible to all of us. But good question.
I didn't want you to put you in a bad spot. Yeah.
No, it's okay, no problem. Then, so this has already been talked about, but I'll just quickly say that yeah, we have worked together with Acton and IPI on these two solutions: cloud door edge aggregation distribution, as well as the PON OLT product. So hopefully, I think these are going into production or are being right now mapped into products at customer sites. This is a view of another ODM vendor. I had to obfuscate a lot of stuff here, but I'm just going to say that we have active programs with others. Just an example, Qumran MX was talked about, high capacity 100 gig device. Then the Qumran AX is a low-end device, and I'll show you more about it, and the 6X. How much time do I have? It's 46, 49.
Go.
Yeah, all right. All right. And then coming up in the future is Jericho Tools, and there are various flavors of 2RU, single RU, and chassis products that are coming. The chassis product will be something in terms of 18 terabits and capacity, and 400 gig products. And this is really, I'll talk more about it in the next slide. Now, going to Qumran, which was something we wanted to discuss more. I've taken a snapshot of what our network, diagram looks like. So we have the eNode Bs that are working with Qumran UX. We have the Qumran AX working with the as the aggregation ring for the mobile backhaul. And then you have the carrier access network where we do use Jericho and Qumran MX. The capacity of a Qumran AX is around 300G. Qumran UX is 120. We use various features there. We have a programmable packet processor, and the customers can choose whatever they want. Importantly, we have table expansion to give that capacity that Lauren was talking about. And that allows you to look up tables, etc. Then, and we offer carrier grade product, so we do provide protection, O&M, SAT, and instrumentation. The other thing that's neat about it is that we have a subscriber-based capability to support subscriber-based SLA. We have a deep buffer traffic manager, hierarchical QS support, and also buffer expansion for buffer memory to be large in DRAM applications. Then we have.
When you say programmable, I'm sorry. Go ahead, Greg.
But this looks like a low cost,
Yes.
low speed.
I don't want lower cost, yeah.
Modest. Modest? How's that?
No, I'm not trying, I don't want to give any.
But it's a lower speed. It's 1 gig, whereas
yeah.
the Tridents and the Jerichos are 10, 2500, right?
Yeah,
so this is clearly a lower speed.
Yes.
Cost effective.
Cost effective is the right word.
Practical cost.
Yeah.
Would this also work in the campus? Like you're pitching it here for mobile backhaul because that's where white box adoption seems poised, and investing there makes sense. But would we see these chipsets?
I think it will be lit. I believe that we have products in the XGS line that are more suitable for campus.
Okay. Yeah.
Okay. And DCI, some of Jericho 2 or Jericho could be used in the DCI market. And it does offer, this product offers up to 100 gig from 1G, 10G, 40 gig, 50 gig, and 20 gig. And it's got a programmable packet processor, as I mentioned. The next slide is a little bigger diagram. And what we're trying to say here is that we have different network function on a single pipeline or a single merchant silicon architecture. So software migration is a lot easier for people to go because we are not really changing, especially on the DNX line and the XGS line. We have different, the software doesn't have to really change, and it progresses through this network end to end. Jericho 2 on the other end, and Jericho here, and then you have the LTE Node B type devices like Qumran UX.
I'm just curious about this. Is this architecture that you have laid out showing the last mile transport and going into aggregation, are these all IP Infusion software integrations that you guys are looking at to solve these use cases?
I believe that quite a bit of this. Qumran UX is coming online, right? Qumran AX is already there. Monterey is not. Monterey is still not an announced product. And we don't know where it's going right now, whether it'll go into ODM. But that's a smaller device. It's a CPRI product. These guys, Firewall 5 is there in the market. IP Infusion has focused on some of the data center devices and the DNX chips like AX, MX, Jericho. And I believe they'll be going to Jericho 2 in the near future. I don't want to speak for them, but I'm just, my hope. So next slide. Here's some of the devices. So we have really covered spine leaf switch architectures, 1RU, 2RU, and chassis. And for various devices, chassis for the edge and the DCI switches. Trident 3 X7, which was the last one we talked, Trident X7 is the last one we announced. And it is actually, Tomahawk 3 was the last one we announced. This was announced last year. It is in production. Fully programmable XGS architecture, 3.2 terabits flexible programming pipeline. Tomahawk 2 and Tomahawk 3 are similar to Tomahawk. They provide fully instrumentation, 100 gig leaf spine, support that, and a low 400 nanosecond latency. Tomahawk 3 is a bump up to a 12.8 terabits with a high radix, 128 by 100, or you can do 32 by 400. On the DNX side, we have Jericho Plus, which is a 1.8 terabit device. Same thing, it's deep buffered. It has 12 to 100 gig, channels or ports with a 1 megabit fib carry grade. Then the Jericho 2, which is coming out, is a 4.8T. But with Ramon, it works at 10 terabits of capacity, okay, when you put it into a chassis. I'll talk quickly about Trident 3. This is a device with a product line that spans from 200 gigabits to 3.2. And there are various flavors of it. These two here, for your question, are enterprise products. This one, and this one. This is data center. can be used in enterprise data centers as well. X2 is more also in the enterprise closet. So more coming. So the smarter programmability allows us to do instrumentation, overlay, load balancing, scalable throughput, XGS class low latency. We have centralized database, fully shared smart buffer that does burst absorption. It looks at thresholds and is able to adjust the bursts accordingly. Then we have low power across the bandwidth. Actually, the lowest power in the industry right now in terms of the 3.2 tera. And we provide the best cost economics for our customers. Some of our ODMs, Delta, Acton, Celestic, and Quanta have implemented the Trident 3 boxes. There may be others I forgot to mention, but now on the Jericho 2, which is the latest, we had announced this, I think, in February. You can provide a 200 terabits per second in a single chassis chipset solution. It has an elastic pipe that gives you groundbreaking packet processor. You can really change the personality of the chip very easily. Distributed and robust packet buffer with optional HBM. HBM is a high buffer memory that's on chip, and that allows you to optionally.
So what you're saying there with the packet processor is the NOS could choose to emphasize some features over another to optimize it for a given use case.
Yes, and what you have to do is really get a firmware load that will apply to that. Right. It's a programmable pipeline, so all you do is get the new firmware load that will allow you to do that.
But they can also do things like add the high-speed memory to increase the size of the TCAMs or to increase the size of the buffers.
Yeah, no, but
so there are packaging options, physical packaging options.
Yeah, with the HBM expansion, etc.
Yeah, as well as software options. So if they've got X stages in the pipeline, I don't know, what's this got, 6 stages in the pipeline or 7?
Yeah, I'm sorry, I'm not able to tell it right now. Yeah.
No, and so, but then it's up to the vendor to decide, or the NOS maker, to decide how they
want to utilize this.
Right.
Device.
So there could be still quite a bit of diversity in products, even though they're running on the same.
Yeah. And in the end, I mean, it really defines the router economics from the power and form factor performance. But yes, programmability is a great option. Of course, we don't give customers the tools. It has to be done by Broadcom. But the software has to be programmed in order to do that, to just answer your question and utilize it is really to talk about the NOS vendor has to write the software in such a way as anticipating the changes and being able to use the APIs accordingly. So Jericho was what we had said before was, we call it the merchant silicon revolution, trying to emphasize how we are taking over the world. Really. In the area of SP aggregation, SP core, and the service provider DC center, Jericho was there. A lot of good features there, SAT, PBR. I think you're familiar with all these. And then we basically teamed up with some companies, and we did quite a bit. There's public announcement on these, AT&T being one of them. And of course, Arista is also a very close partner, and Cisco. And then as Jericho 2 came in, we added state segment routing, 400E service activation testing, VXLAN, EPPN, and BR multicast is a bit, I don't know the exact acronym, but it is a new form of doing multicast, bit encoded in multicast, something like that. So the next slide is really the last one. And we have one more. What we have done, what Jericho has been able to do as a merchant silicon vendor, has really taken this OEM ASIC 18 times, added a capacity of 18 times into a chassis of the same size. And also enabled people to be able to take the same silicon and disaggregate into several boxes of routers. So you can choose here or there, and so that's where the white box comes in, right? You can do the chassis or the boxes and implement this core router easily. So this really enables the white box and the disaggregation economics.
I'm kind of surprised there's enough market for chassis in the modern era where, like, we've seen companies build chassis out of 1RU boxes. the idea that you're still producing silicon that's optimized for chassis usage kind of baffles me a little.
The high-end routers, okay,
Right.
Is where it is. DCI also needs these chassis when you're talking about large-scale data centers.
We talk about terabit class routing engines.
Yeah.
And we'd need hundreds of interfaces.
Yes, exactly.
Or they'd need lots of Jericho Tools.
They need
Not
lots
just
of
one. They need.
Yeah.
They take a dozen or a couple of dozen of them to get a high speed.
Yeah, I mean, this is basically this, right? I mean, it's just flattened out like we do with server blades. Server blade versus, rack-mounted servers. I mean, you're basically doing the same thing. You're taking those things and flattening it
Are
out.
you doing that? You're not doing the chassis design and the metalwork and the airflow and the power supply design. You're just producing the ASICs.
Yeah, we are not like what Intel did in the PC market, where they actually did like the board and everything, and everybody was just using board, and the value was really in the silicon and the CPUs. So, no, we are not there yet. Although we, of course, have to recommend the power, the power map and the color map for the temperature and everything, and tell the customer how the airflow should be, because these are heavy dudes. They take a lot of power, not a huge lot, but considering the functionality it's doing, they're not taking as much power.
Intel designed those boards as a reaction to poor quality implementations. So, they came out with the reference boards.
Yeah, exactly.
And the chassis designs to guarantee a certain level of production quality.
Yes, exactly.
I don't want to imply that that's yet happened, but it might.
Well, ATCA was one example where somebody tried and didn't work, but and that helped the disaggregation market. So I think that's what is happening. But these vendors, Odium, are very high quality people. I mean, our relations with them are really strong, and we exchange roadmaps on a daily basis.
It's in their interest not to make you do it, I think.
Yes, yeah. So we don't see a lot of problem with the boards really on our side. Then, so the last slide basically talks about, unparalleled router economics at 100 and 400 gig edge core network is one of our partners. We also have Conta, and we are developing products. And the reason we show the disk is that software is required, of course, that being our partner here. And we expect that the first ODM router system will be available in Q4 at market disrupting prices. So hold the breath. Okay, so in conclusion, thank you. We are, as Broadcom, very committed to the disaggregated market. We feel there's a huge market coming, and it's gonna completely go out of crazy. But you know that Facebook and everybody is now disaggregated. So thank you very much.
One question before we completely wrap. Any shipping ASICs currently with IPv6 VXLAN channel endpoint termination capabilities?
I'll have to check. Okay, we do support IPv6. We support VXLAN. Now, whether we do it on a V6 underlay.
I know that most
I'm not able to tell you right now.
As far as Trident 2 and older chipsets, we can only do IPv4.
Yes.
For VTAP. So on the underlay, you have to have IPv4. I'm just wondering what the state is for getting IPv6.
I do believe it is there on Trident 3 X7.
Okay.
One of the things that I didn't tell you was that all these devices share the same pipeline, the X7 Trident 3 family. So software migration is very similar to what is in the DNX, that you can migrate to various devices. But I do believe that the X7 has that capability, but I'll need to check.
Okay.